All right, so here's the concept. It says linearization, if f is differentiable at x equals a, then the equation of the tangent line. So this is just a tangent line. And it says defines the linearization of f at x equals a. Relax, that's just a tangent line. The approximation f of x equals L of x, and the standard linear approximation of f at x equals at a of f at a. The point x equals a is the center of the approximation. Okay, what does all this mean? All it means, guys, focus. All it means is if you find a tangent line for a curve, you can use the tangent line to approximate the curve, but only if you zoom in extreme, only for values really close to the point, to the center, to your point of tangency. Because this is saying, what this is saying right here, everything that I just circled right here, it's just saying that if you zoom in, your tangent line and your curve look almost identical. So let me give you, let's try this out, guys. Let's go to Desmos really quick, so you guys can see what I'm talking about. Because the topic is not that bad if you understand what they're doing. Open graphing calculator. So let's do a simple one, like y equals x squared. Y equals x squared. And the derivative of x squared is 2x, right? And then the point, I'm going to just do the point of tangency at the point 1, 1. So I'm going to write y minus 1 equals, let's see, 2x. 2 times 1 is 2. So the slope is 2x minus 1. Okay, so there it is. Do you guys see how this is, my point of tangency is 1, 1. Like that's where I'm finding my tangent line of this curve. And look what happens. If I zoom in a lot, notice that tangent line and that curve blend in. Do you guys notice that? So all we're doing is we're going to approximate the curve by using the tangent line. And it's really, really good approximation only if you're really close to the point of tangency. Obviously, at the point of tangency, it's perfect because the curve and the tangent line share that same point. But if I move away from that point of tangency, the approximation is really good for the curve. As long as you're close to the center, and the center is the point of tangency. The further away you get, look how it just gets further and further away. The further away you get from the point 1, 1, the worse the approximation is for the curve x squared. Does that make sense, guys? So that's all you're doing. I hope that makes sense. So let me repeat just in case. What are we doing? We're finding a tangent line, and we're using that tangent line to approximate the curve, as long as we're really close to the point of tangent. The further away we get from the point of tangent, the worse the approximation is. Does that make sense? Okay. And then when you get to BC, Cal BC, for those of you that are going to take Cal 2 at the university, you'll do something else called Newton's method. But we're not there yet. You're not there. We're just doing rookie stuff. All right, so check it out. It says find the linearization. Relax. Don't freak out. All that just means is tangent line of f of x equals square root of f of x equals square root of x at x equals 4, and use it to approximate the square root of 4.02 without a calculator. Then use the calculator to determine the accuracy of the approximation. Okay, I will be 100% with you guys. We're in 2024. You're probably never going to use linearization to approximate something because you have calculators and computers. But back in the day, this is the method that they used. This is actually the logic that is used in your calculator to some extent, the algorithm to approximate, and then it figures out a tolerance, and then once it figures out the tolerance, it spits out an answer. All right, so here we go. What do I need? I need a point and a slope. So my point is 4, comma, the square root of 4 is 2. All I did was just square root of 4, right? And now I need a slope. So I'm going to go f of x equals square root of x, which is the same thing as x to the half. And hopefully by now we're getting so good at this. F prime of x is equal to 1/2 x to the negative 1/2, which is the same thing as 1 over 2 square root of x. All I did was take a derivative because I want my tangent slope. I'm going to plug in 4. 1 over 2 square root of 4, so 1 over 2 times 2, so 1/4. So here's my tangent that they call linearization. Sometimes they use L of x. I'm not going to bother. I used to always do this format, but just write your tangent line. So here's my tangent line. Y minus 2 equals 1/4 x minus 4. Have I confused anyone? Okay. This is my tangent line. This is what I'm going to use to approximate f of 4.02. That's what they want me to approximate. Approximate f of 4.02 because they want what is, square root of 4.02. See? So I'm going to plug in right here into that x 4.02. So let's see. F of 4.02 is approximately, no, I'm using the tangent line to figure out what the square root of 4.02 is. So I'm using the tangent line to approximate that. 1/4, 4.02 minus 4 plus 2. Is anyone freaking out? Okay, let's see what this is. This is 1/4 times 0.02 plus 2. Dang, what's 0.02 in fraction? Is it 1/50th? 0.02? Yeah, it's 1/50th. You guys told me no. I was already freaking out. 4 times 5, 20, so that's 200. 1 over 200 plus 2. So 2 times 2 is 400 plus 1. So 401 over 200. Whatever that number is. 2 point, some number just a little bit bigger than 2. 2.01, I think, or 2.001. Let's find out. Ready, guys? This is what I told you. You need your calculator. So I'm going to go 401 divided by 200, 2.005. All right, let's see how close this is to the actual row value. So square root, what was I approximating again? 4.02. 4.02. Enter. Yeah, that is pretty darn close. Look how close that is. I take this number, I subtract this one, and you are only 0.0000, did I say 5 zeros? 623 away from the actual row answer. That's pretty darn close. You don't think that's pretty close? You're not impressed? You're like, I'm not impressed. It's pretty close, guys. It's really close. Let's make sure I didn't make any mistakes, because I make mistakes all the time. 140, 1/4 times 150, that is 1/200 plus 2. 2 times 200, 2 times 2, 4 plus 1, 401. Yeah, everything looks correct. 2 plus 1 over 200. Yep, everything looks good, guys. We're good. All right, let's see. Let's continue. We're just practicing. Oh, this is your approximate. And they wanted me to say, then use the calculator to determine the accuracy of the approximation. So the error using calculator equals square root of 4.02 minus 401 over 200, which gave me 6.234.0000006. Let me see if I can do that. 0.000012345 This was my error. Error in approximation. This is my approximation, and this is the error in the approximation, because they wanted me to do two things. They wanted me to approximate and then to find the accuracy. You know what I mean? And that's it. That's it. All right. So we're just practicing, guys. That's all we're doing. The trick is to find a point really, really close to the square. Don't worry. They're going to give you the model when we take the row AP exam. We're going to do a real question in a little bit. So think of a point that is that's really close to the square root of 123, a perfect square root. What's the perfect square root to 123? Really, really close. Yeah, 121. What's the square root of 121? 11. So the number I'm going to choose is 121.11. This is going to be my point of tangency. Point of tangency. That's where I'm going to find my tangent line. The function is going to be square root of x. Yeah, no, I agree. I agree with you. When are you ever going to use this? Never, probably. You'll just use your calculator to approximate what the square root of 123 is.
Wait, so on the test you use a calculator?
No, on the test there's not going to be a calculator. Look, I'll show you. Usually I don't like to show this in advance. I think I stole this from a previous exam, but this one comes with data. Look at this one. See, this is question 19, and it's no calculator. And 57% of the population got it correct. But we're getting ahead of ourselves. Let's practice really quick, guys. All right, so here we go. I need a point and I need a slope. So the function I already know is square root of x. I already know my point. So I already know that f prime of x, that I did a little while ago, is 1 over 2 square root of x, unless I messed up. Chav, how do you know it's that? I got it a little while ago. Come on, focus, guys. So f prime of 121 is 1 over 2 square root of 121, which is 1 over 2 times 11. 1 over 22. That's your slope. Is everyone okay so far? All right, tangent line. What's my tangent? Y minus 11 equals 1 over 22, parenthesis, x minus 121. This is what you're going to use to approximate. Use tangent line to approximate square root of 123. So I'm going to go f of 123, because f of x is approximately 1 over 22. I'm just using this parenthesis, and I'm going to plug in 123 minus 121, close it, plus 11. Is anyone freaking out? Okay. You're done. This is your approximation, guys. Let's see, 1 over 22 times 2 plus 11. So it looks like it's going to be 2 goes into 22 11 times. So 11 and 1 over 11. So 121, 122 over 11. That's your approximate. Let's put a decimal. Let me put it as a decimal. 11 point, what's 1 over 11? 1 divided by 11. I feel like it's a repeating one. 0.090909090909. Love it. 09090909 goes on forever. That's the approximate. That's all it wants. Easier to say to approximate. Let's see how close it is to the real one, to the square root of 123. So I'm going to take my calculator and square root of 123. Oh, look at that. I'm going to subtract 11.0909090909. That's enough. It's not as close as the other one. 0.00003. Wait, did I say an extra 0? 0.00003. 0.0003. I keep saying an extra 0. Okay. Cool or not cool? Okay, so that's all it wants, guys. Be careful. This one's a cube root. So the function is the cube root of x. And the closest perfect cube root is 125. So this is just practice. So point of tangency, 125, comma, the cube root of 125 is 5. Yeah, know your cube roots, guys. Just the basic ones. So from there, we just got to find a tangent line or tangent slope. We just take a what? Yeah, just a derivative. So I'm going to rewrite it. X to the 1/3. And let's just take a derivative. F prime of x equals 1/3 x to the negative 2/3. So let's see, 1 over 3 cube root of x squared. That's what it means. Let's see if we can do this without a calculator. F prime, this is my point of tangency, so I'm going to plug in 125. So 1 over 3 cube root of 125 squared. So I'm going to write it like this. 125 times 125. Yeah, we don't need. This was 5 times 5 times 5. This was 5 times 5 times 5. I don't have to show that, but I'm doing it just so you guys know what this is. This is the cube root of 5. So 5 times 5 is 25. So you get 1. And I'll slow down. Let me explain what I'm doing, guys. all I'm doing is just breaking this out, right? Just using your law of exponents. We know the cube root of 125 is 5, but there's two 125s, so you get 5 times 5. And then we know 5 times 5 is 25. We've been doing that since, like, I don't know, third grade or whatever. And then 25 times 3 is 75. So your slope is 1 over 75. Does that make sense, guys? Yay. Okay, that was the hard part. We're done. You're just going to plug in. So here's your tangent line. You're going to go y minus 5 equals 1 over 75, parenthesis, x minus 125. And I'm going to write, this is your tangent. Use tangent to approximate the cube root of 123. So what am I going to plug in for that x? Yeah, 123. So here it is. F of x, or f of 123, is approximately 1 over 75, parenthesis, 123 minus 125, close it, plus 5. And I'm going to tell you a secret. Well, it's not a secret, but if you get I feel like it's too early to tell you this, but I already started, so I'm going to tell you. If you get a free response question and they ask you to approximate, you can leave it like that. And that will be full credit. It's too early to tell you that, but I already did. So usually I don't tell you that until the second semester. But let's see what this is. Let's see what this number is. Negative 2 plus 5. What is it? 1 over 75 times negative 2 plus 5. 4.97333. Let's see what the real one is. Cube root. By the way, how do I find cube root on the calculator? Math. And there it is, number 4. Check it out. Number 5 is for any root. 5th root, 6th root, 7th root, 10th root, 11th root. But there it is, guys. And you don't need this. You could have also raised it to the 1/3. Look, number 4. Third root. What number was it again? I already forgot. 123. Let's see how close it is. Look at that. Look how close that number is, guys. By the way, you don't need the cube root. You could have just done this. Parenthesis 123, close it to the power 1/3. You could have done this. And it's the same thing. It's the same thing. Just make sure you know how to use your calculator, guys. You can be so fast with this calculator.
So I box an answer.
Oh, the answer for this one is right here.
Okay.
Because what was the question? Use linearization to approximate. They wanted you to approximate the cube root of 123.
It's a lot of work. I just need confirmation that's the answer.
Yeah. Okay. But I just wanted to show you how close it was. Okay. All right, guys. We're done. Look at these questions. Now we're just going to see if we can know how to do them. I should have done a poll, but I didn't get a chance to insert it. I'm pretty sure I stole this question from one of the old AP exams. I just don't remember which one. It says, do you guys know how to find percent error? No. This one, you need a calculator. Okay, here we go. If the linearization of the cube root of x at 64 is used to approximate the cube root of 66, what is the percent error? All right. First, tangent line, guys. So here's my tangent line. 64, comma, what's the cube root of 64? 4. Plus you have a calculator for that one. So you could have used it. All right, next, I need a tangent line. We already know that the derivative of this, because we just did it right here, the cube root of that, 1 over 3 cube root of x squared. 1 over 3 cube root of x squared. Chop, how do you know? We just did it. We just did it a little while ago. Y prime evaluated at 64 equals 1 over 3 cube root of 64 times 64. I haven't done anything crazy, guys. 1 over 3. The cube root of 64 is 4. So I have 4 times 4, which is 16. Are we still okay? 16 times 3 is 48. So there's my slope. I'm going to use that tangent line to find the approximate. But notice they want the percent error. So here we go. I'm going to go y minus 4 equals 1 over 48, parenthesis, x minus 64 close. This is a tangent line. What value am I going to put there for that x? 66. Perfect. So f of 66 is approximate 1 over 48, parenthesis, 66 minus 64, close, plus 4. Take your calculator. Let's see what that number is. 1 over 48, alpha fraction, enter. I usually don't use a fraction thing, but I want to. Times 2 plus short-term memory plus 4. Okay, there's my approximate. 97 over 24. I'm going to store it to a letter. That way I don't have to deal with it. I stored it to a letter, guys. That way I don't have to deal with it. Oh, let me turn this guy off. Okay. Whatever this is, I stored it to A. So wherever you see A, that's what I'm using. Ready for the percent error? Percent error. Hopefully you remember from your physics classes or your chemistry classes. It's just the difference divided by the actual. So difference, the absolute value, divided by the actual times 100. That's how you get percent error, guys. So difference, so I'm going to go absolute value of A minus, let's see, cube root of 66. Whatever I get, I'm going to divide it by the cube root of 66 times it by 100. And that's your percent error. You've done that before, right? I hope in chemistry class or in some type of science class. Okay, good. All right, here we go. I'm going to go, let's see, what am I going to do? Alpha A, because that's where I have it stored, minus the cube root. What number was it? 66? Okay, enter. There it is. I'm going to divide that by the cube root. I keep pushing second. Of 66. And I'm going to times it by 100. Man, that is such a small error. 0.01%. I bet you a lot of people got that one wrong. 0.01%. Letter A. All right, guys. Sorry I didn't ask a poll on this one. I don't remember what year. Oh, they're about to be a fire drill. I heard a whistle. Did you hear it? Oh, it's a walkie-talkie. Oh, yeah. Ramos, I'm going to make you in charge. And I got in trouble last time. Yeah, we're all one. So you're at the door first. If you do a really good job and we get appraised really good, we'll have tacos in here. All right. Here we go, guys. This is a real question from a real AP exam. Do you guys want to take 2 minutes to see if you guys can figure it out? Take 2 minutes, guys. Take 2 minutes. See if you guys can figure it out. No calculator on this question, guys. And Mila, where are they at? All right, guys, give it a shot. Give it a shot. All right, I'm going to go ahead and start. If you're pretty close to getting an answer, keep going. Let f be the function given by 2 cosine x plus 1. What is the approximation for, I guess, for f of 1.5 found using the line tangent to the graph at x equals pi over 2? I need a tangent line. Point and slope. If x is pi over 2, you need a little bit of pre-cal. Cosine of pi over 2 is 0, and 0 plus 1 is 1. So your point is pi over 2 comma 1. Does everyone see how we got that? All I did was just plug in here, Mejia. Cosine of pi over 2 is 0. That's how you get your point, right? Okay. All right, next. How do I get my slope? Derivative. Derivative. F prime of x equals, what's the derivative of cosine? So negative 2 sine x. I'm going to insert pi over 2. Sine of pi over 2 is 1. Thank you. So my slope is negative 2. They want me to use this tangent line, y minus 1 equals negative 2x minus pi over 2. They want me to use this tangent line to approximate f of 1.5. Use tangent line to approximate f of 1.5. Okay, so I'm going to move the 1 to the other side, and I'm going to insert what value for x? 1.5. But it's easier, instead of inserting 1.5, it's easier to insert 3 over 2. That's the hack here. Do you guys see that? So I'm going to write f of 1.5 is approximately negative 2 parenthesis 3 over 2 minus pi over 2 plus 1. It's okay to write an equal sign now because that's what this expression equals. Negative 2, 3 minus pi over 2 plus 1. I'll slow down. When I distribute negative 2 times this, the 2's cancel out, but don't forget to distribute the negative. So I have a positive pi minus 3 plus 1. So pi minus 2 is the answer. 57% of the total population got this question correct. Good job. Good job. All right, and now it's just a few practice questions. We're just going to do 2 of them because we're not ready for the third one yet. Hopefully before we leave for Gobble Gobble, we'll be ready. All right, here we go. Let f be a differential function such that f of negative 5 equals negative 2. Here's your point. You have a point. And f prime negative 5 equals 9. This is your tangent slope. Tangent slope at negative 5, negative 2. What is the approximation for f of negative 4.85 using the tangent line of f at x equals negative 5? So they want you to use the tangent line to approximate f of negative 4.85. You're going to need your calculators. So here we go. Tangent line first. Tangent line. I'm going to go y plus 2 equals 9 x plus 5. Is everyone okay with that? Okay. Use this tangent line to approximate f of negative 4.85. So I'm going to write f of negative 4.85 is approximate 9 parenthesis negative 4.85 plus 5 close minus 2. All I did was just move the 2 to the other side. I take my calculator. 9, let's see if I can remember. 9 negative 4.85, was it plus 5? Plus 5, and then what was the final? Plus 1? Minus 2. Bad short-term memory. Minus 2. And there it is, negative 0.65. So negative 0.65. There's your approximate. How do we feel? Nothing crazy, right? Let's do one more, and then we'll set you guys loose. You just have 7 questions on delta, and then do your bonus. Oh yeah, you know what? You guys were right, but it's too late now. That's why I put the due date for the bonus for Monday, because we were gonna have the test Tuesday. Man, how did I mess that up so bad? It's because we have a chess tournament this Saturday, and the amount of paperwork that I've done in the last 3 days has been crazy. I think I should leave it today, unless you think, okay, I'll move it to Wednesday. But that doesn't mean like, oh, yeah, no, like take care of some of it today, guys. Like, you're gonna finish the 7 questions real quick, so I would take care of some of it today. All right, here we go. Last one. Let f be differentiable function such that, here's my point, negative 2, 3. All right, guys, focus. And here's my derivative. What is the approximation of f of negative 2.05? Plug in a negative 2 into that derivative function. F prime of negative 2 equals 5 times negative 2 plus 5. Chav, why are we plugging in a negative 2? Because you want your slope at x equals negative 2. So now we have negative 10 plus 5, so negative 5. I don't see anything crazy. Here we go. Tangent line. Tangent line is y minus 3 equals negative 5 parenthesis x plus 2. You're going to use the tangent line to approximate f of negative 2.05. So all you're going to do is move the 3 to the other side, and that's your tangent line. F of negative 2.05 is approximately negative 5 parenthesis negative 2.05 plus 2, close it, plus 3. Take your calculator. Let's see if I can remember. Negative 5. Negative 5 parenthesis negative 2.05 plus 2. I know that's negative 0.05, but just in case, so we won't make any mistakes, plus 3. Plus 3. And there it is, 3.25. That's the approximate. You don't know what says? Oh. All right. Later on, guys, don't worry, we're not going to do this question here. Hopefully we get to it. I just want to give you guys, real quick, guys, listen real quick, because I want to make sure that we understand this. All right. Later on, they're going to start asking you, is it an over approximation or an under approximation? All of that depends on the concavity of the curve. Think about it. Just think about it for a little bit. If you're concave up and you find a tangent line, every point on that tangent line, is it above the curve or below the curve? Yeah, every point is below the curve except for the point of tangency. So if I'm concave up, the tangent line is going to give you a under approximation. Does that make sense? If you're concave down, look, here's concave down and here's your tangent line. If you're concave down, that tangent line is going to give you a over approximation because the tangent line is above the curve. Does that make sense, guys? We're not there yet. We will talk about how we find concave up, concave down, hopefully before gobble gobble. And that's it, guys. Just take care of the delta, and we're done. Gobble, gobble, gobble. Take care of business.